Imagine your body as an exclusive nightclub. The immune system is the imposing bouncer at the front door. His entire job is to check IDs and aggressively toss out dangerous intruders, like infectious viruses and bacteria. But here's the problem. Our bouncer is incredibly strong, but not always very smart. Sometimes he panics over something entirely harmless. Or worse, he gets confused and starts smashing up the furniture inside the club. Because of this, medical treatment often comes down to managing this bouncer's 3 primary moods. We learn to calm him down, how to train him, or even sedate him. When doctors look at an illness, they determine which of these 3 moods is at play, so they can nudge the system back into a safe, healthy balance. Let's start with the bouncer's first problem mood, an excessive, harmful overreaction. In a clinic, this is called a hypersensitivity reaction. This diagram shows type 1, or immediate hypersensitivity. This is what happens when the bouncer misidentifies a harmless visitor, like a peanut. Within seconds, the immune system hits the panic button and floods the area with histamine, causing blood vessels to swell instantly. To stop this, we have to forcefully turn off that chemical alarm system. That is why we use medications like antihistamines, or in an emergency, a shot of adrenaline. Then there is type 2 hypersensitivity, which operates like friendly fire. Instead of reacting to an outside allergen, the immune system mistakenly places target signs directly onto your own healthy cells, ordering their destruction. We see this during a mismatched blood transfusion. If a patient receives the wrong blood type, their immune system immediately sees those new, healthy blood cells as threats and destroys them. In both of these scenarios, the tissue damage isn't caused by an actual virus. It happens entirely because the immune system acts aggressively on a case of mistaken identity. The third type of hypersensitivity is more of a messy cleanup job. Here, the immune system properly identifies the invaders, but it fails to actually clear them out of the club. Looking at this illustration, you can see how these tangled pairs clump together. They get lodged in narrow spots like blood vessels or joints, causing the painful, long-term inflammation seen in conditions like lupus or rheumatoid arthritis. Finally, there is type 4 hypersensitivity. This one is unique because it skips the fast-acting chemicals and relies on slow-moving immune cells called T cells. Because these cells take time to mobilize, the reaction takes anywhere from 1 to 3 days to show up. This delay explains why touching poison ivy doesn't cause an immediate reaction. It takes time for those slow cells to arrive and cause an itchy red rash. Doctors use this specific delay to their advantage when performing skin tests for allergies. By watching the timeline of a reaction, whether it happens instantly or days later, doctors can tell exactly which part of your immune system is misfiring. That covers the overreactions. But what happens when our bouncer is caught off guard by a new threat? That brings us to his second mood, unpreparedness. To fix this, we use immunostimulation. Immunostimulation is the intentional activation of your immune system. The goal is to train biological defenses to recognize specific threats before an infection starts. Vaccines are the most common tool. A vaccine introduces a harmless, weakened piece of a virus, handing the immune system a mugshot. The body sees this mugshot and creates a long-term memory of the intruder. Think of a vaccine as a training exercise. It prepares your biological defenses so they are ready long before an actual infection arrives. Specific immunostimulation works by exploiting a built-in feature of your immune system, its remarkable ability to hold a lifelong grudge against any invader it recognizes. Sometimes, however, we want the immune system to ignore a foreign object. When a patient receives a heart or kidney transplant, the immune system will correctly identify that new organ as foreign and try to destroy it. To prevent this, doctors use immunosuppression. This involves using drugs like corticosteroids or specific chemicals that block the internal signals telling the immune system to multiply and attack. These medications act like a sedative for our bouncer. They lower the body's natural defenses just enough to prevent the rejection of the new organ or to stop an autoimmune attack. This therapy carries a heavy price. When you sedate the immune system to save a transplanted organ, you remove the patient's primary defense, leaving them highly vulnerable to everyday germs. This makes immunosuppression a calculated medical compromise. It is the choice to trade the risk of a common infection for the survival of a vital organ.
Stopping an allergy, giving a flu shot, and protecting a new heart might look like three different goals, but they all involve manipulating the exact same biological security system. We often think we want a stronger immune system, but an aggressive bouncer creates its own problems. Real protection comes from a system that is precisely tuned to distinguish a threat from a friend. Managing health is a constant adjustment. If the immune volume is pushed up to 10, you get hypersensitivity and inflammation. If it is pulled down to a 1, you are left unprotected. The goal is to settle perfectly in the middle. Doctors act as DJs for this system, turning the volume up to build defenses or down to prevent friendly fire. So the next time you take a daily allergy pill, remember what's happening. You aren't fighting off a disease. You are just sliding a bribe to your bouncer, asking him to please look the other way when the pollen arrives.